Hello everyone, welcome back. Hope you are doing fantastic and following along. In previous sessions, we delved into the world of Docker, where we covered essential topics such as Docker build operations and Docker run operations. We also explored various Docker commands to help you navigate this powerful containerization technology effectively. Today we will dive a little deeper, and in this session we will talk about some advanced Docker commands and functions that will elevate your Docker skills to the next level. But before we jump into the exciting new content, let's take a moment to revisit and reinforce our understanding of some key concepts, commands we have previously explored. This recap will not only serve as a refresher but also provide a solid foundation for our upcoming discussions. So stay tuned as we revisit and then venture into the world of advanced Docker commands. Now let's get started. In previous sessions, we started with systemctl start docker and containerd commands. We use this command to start the Docker services because, as I said, whenever we are rebooting or restarting our systems, we need to make sure that we need to start our Docker and containerd services to make the Docker daemon functional. However, we have many ways to automate this particular commands using cron job and all, but I am highlighting here again and again so that you should remember this particular concepts. If your services are not running, you won't be able to perform any operations in your Docker node. Then we used systemctl status docker containerd command to validate the status of the services those are running. And then once the daemon is running, we used docker -- version command to validate the functionality of the services, functionality of the Docker daemon, and its final status and version. Then going further, we used docker login command to log in into the Docker Hub registry from the Docker node so that we can access our private repositories and registries from our Docker node to access the images that we had stored or pull the images that we are creating. Then we perform Docker build operations. During Docker build operations, we use Docker image build command to convert the Docker file into Docker image. And then we use docker image ls command to list all the images those are locally stored in a particular Docker node. And then we use docker tag command to tag the images which are locally stored in the local tag format, and we tagged it into the desired format of Docker Hub repositories. And then we use docker image push command to push the images that we created, and those are locally stored at present. So we pushed these images to the Docker Hub repository so that it can be used centrally from multiple systems. Then in next session, we performed Docker run operations, where what we did is we used docker image pull command to pull the images from the Docker Hub repositories using public repository and private repository. Then we use docker run command to run the containers using the Docker images that we have built. And then we use docker container ls command to list the containers which are running on the Docker daemon. These are the few commands that we used so far in our previous sessions. In today's session, we are going to use some additional command. For that purpose, what I have done is I have already started my virtual box and these two dev and prod node which are running. And we have also accessed these two nodes using the CLI, as you can see here. So now let's proceed with some advanced command. We used docker version command in previous session, which shows just the version of the Docker daemon which is running. You can see here. What if you need very detailed information about the Docker node that you are using for your diagnosis and additional purposes, use cases? So for that purpose, we need to use docker info command. As you can see, this command shows a very detailed information, but still it is saying these Docker daemon services are not running. That's why we are still getting some limited outputs only. With the help of this command, you can see some basic information which is addition to the version command, but it will also show you the status of whether the Docker daemon service is running or not. As you can see here, Docker daemon service is not running. So what we are going to do is we'll copy the command from here and we will start the Docker daemon service. We'll do the same for my both the nodes. We'll run the same command again to get a very detailed information. Once the Docker daemon is started, initially we got very basic information, this much only. But once the Docker is started, Docker daemon is started, we can see we got very detailed information, additional information for our diagnosis purposes. As you can see, it is talking about the edition, which is community edition of the Docker engine that we are using. It is talking about the version, and then a debug mode which is false by default, that you can enable based on the requirement if you need. And then server details, it is saying that it has no containers, nothing, no running containers, pause containers or stopped containers. It has only one image which is running here. And then it is talking about the versions again, and then many other storage related information. And then at the end you will see the node information, which is type, operating system, which is CentOS Linux 7, and additional commands, additional information like CPU, 2 vCPUs, total memories, and the name of the system, everything which is visible here. So you can use this command to get a very detailed information about the Docker node that you are using. That will help you to validate the compatibility, performance, and the usability of your particular Docker node. Now we will perform some image management functions here. What we had done in previous sessions, we built image. Now let's say there is some problem during the build process, or some other thing is happening. You want to inspect after creation, after building the image, you want to validate your status of the image that you have created, or the detailed of the image that you have created, right? You can use this command, let's say. But before that, let me docker image ls. Let me list the number of images which are stored here. So we have two images. Basically, one is locally stored and the other one is the replica of the same image, which is in the format of the Docker Hub repositories. What I'll do is I will simply run docker image inspect command followed by the image ID. Then you see what all the information it is going to show. Looks like some typo. Inspect, yeah. Here we are. So as you can see, we executed docker image inspect command followed by the image ID that we wanted to investigate or find the detailed information about the image. You can see we got these many information. You can see it is talking about all the configuration specifications that we had defined. But just because we had created a very basic image, very basic file, Docker file for the very basic image, so that you can make it understand easily. I don't want to make you complete DevOps here. I want to make you understand the basic foundation of the Docker and Kubernetes, so that you can understand the depth of the network and security once we'll start talking about that. So we are building foundation for Docker so far. That's why I'm not going too deep into the DevOps side, because if we are creating a proper prod grade Docker image, then in that case you need to fill a very detailed information that requires for your application compatibility and performance requirements. So you can see we have not defined much. That's why all the information are showing false and nil. And then here you can say we had defined just the exposed port, which is TCP 22. So let's say after creating the image, you forget what is the port that you are exposing. Then you can use docker inspect command to validate the detailed configuration of the image that is built. You can see what all the ports are exposed, what all the things you have defined, what all the specifications you have given. Everything will be defined here using this command. You can explore it. Then the next command is docker image history. Let's say you build an image and you want to see the history of the build process. What you can do, again, you need to perform docker image history. Instead of inspect, we need to use history. And you can see the creation process. The same process that we saw on the screen when we were building, right? So we saw it executed multiple commands that we had defined in our Docker file, and then it exposed the ports and all, everything that whatever we had defined in our Docker file, right? It is explaining here. We can get all those information from here. Then we can use docker image rm command to delete the images. We will perform this in our, let's say we have two images here, docker image ls. We need these images to perform our additional operations. So we are not going to perform docker image rm command right now. We'll perform it later at the end of this session. Now let's try to understand the container management commands. So previously we used docker container ls command, which is used to list down the containers which are running and functional. Let's do it here. We can see one container is running. But as we can see, with the help of docker info, we can see this is saying there are two containers, which one is in running state, one is in stopped state. But why the other container is not visible here with this command? So for that purpose, because this command, as I said, this command only shows the containers which are running and in functional state. But the other container is in stopped state or in error state. That's why we are not able to list that particular container. So to list non-functional containers or to list all the containers which are in functional state or non-functional state, we should use docker container ls along with -a statements, which means all the containers. We can see we are able to list both the containers now. There is another command, as you can see here. So we can use docker container ls to list the container which are running in functional state, and we can use docker container ls -a to list all the containers whether it is in functional state or in non-functional state. Similarly, we can use another command for the same output, which is docker container ps. Let's run and see the output here. We can see we are getting the container output which are in running and functional state, and then if I will include -a, it is going to show me all the containers regardless of its status, whether it is functional or non-functional. Now the another command that I want to talk here is docker container start command. Let's say what my docker info command is saying here. It is saying I have two containers, one is in running state, the another one is stopped state. That means we can use these two commands, start and stop commands, to start the containers, any stopped containers, or to stop any running containers of also. Because as we said, right, so containers are the micro compute instances. That means if these are the compute instances, we can restart them, we can start them, stop them at any point in time. So if it is in a stopped state, what we can do is we can start them using the docker container start command. Let's execute and see the difference. What I'm saying, I'm trying to start the same system which is created but in non-functional state. Let's do that and see the impact. I can say I'm getting some error. We are going to talk about this error later. And then what we can do is we can use a stop command to stop a running container also. So what I'm going to do is I will use a stop command, and my Ubuntu is running state. So this is my running container. I'll stop it first, and then you can see ps command or ls command is not able to find this particular container which is in non-functional state or stopped state. We'll use -a keyword to list all the containers. So we can see we have two containers. One is a Ubuntu sys, which is in exited state, and the other one is in created state. Both are in non-functional state. What we are going to do is now we will use our start command to restart the Ubuntu system once again. This one. Here we are. It started working. Now that means we can list it without the ls command. Now we have another command which is called docker container inspect command. This command is used for two purposes. One is to find the detailed information about the container which is running or which is created, whether it is functional in running state or non-functional in stopped state. But you can use the same command to get the detailed information about the containers. Let's try to find the detailed information about the running container first and see what all the information we are going to get. We are going to get very detailed information about the containers. We can see the state information which is running, and then we are going to get spec information also, detailed specification, what all the things that is defined in this particular in the docker file to create the docker image, and then the same image which is being used for running containers. You can see whatever pose we have exported are visible here. So we can get all the detailed information about the image that is running, including the IP address and all, many detailed information here. And the other use case of the same command is to find the errors. What is the reason when container is not running, or any problematic container? What we can do is, just because we have two containers, one is running normally, the other one is in non-functional state. So we run this command to find the detailed information of functional container. Now we'll run the same command to find the error, why this container is not coming into running state. For that purpose, I'm going to execute a command called inspect again with the non-functional or the container which is in error state, to see what is the reason why it is not coming up. Let's go a little up and find the reason here. So container state is this one, and here is the error. We can see driver failed programming external connectivity on the endpoint. Now just because if we are starting it, we are getting the error on the screen, but let's say someone else has created the container. Now you want to go and find the reason, you may not able to see that particular error that was coming at the time of execution on your screen. So with the help of this command, you can go and check what is the reason why my system is or container is not coming up. You can see the reason because we are using duplicate port configuration. That's why my container is failed to run. Now what I'll do is, I will solve this problem first. I will create another container with correct port information. Here we are. And I'll give new name because we cannot use same name here. Name should be unique. And container got started. Let's see, container docker container ls. We have two containers in functional state. Now what we are going to do is, before showing the output of this log command, I will stop web system container here. So we will use docker container stop. So now we will use a stop command to stop web system container, and then we'll restart it again. So my system is in stopped state. We'll use -a to list the stopped container. We can see web sys3 is in stopped state now, exited state. We'll start it again. Command got executed without any problem. Let's list the container. My containers are in running. These are the two commands that we can use to stop or start the containers effectively. Now in order to show you the output of this command, I'll execute this first and then I'll do something, tweak something to show you the use case of this command. I'm executing this command followed by the container ID, which is this one. So see, it is giving me error here. You can see what it is saying. So basically we can use docker container inspect command to inspect the problem, any problem that is happening at the Docker daemon level. That means if a container failed to start or a container is in error state because of the problem at the daemon level, then you can inspect or diagnose that particular problem using the docker container inspect command. But if the problem is inside the container itself, then you need to use docker container logs command. This command shows the logs of the container itself. That means if we get into a system and we execute some command to find the logs, we can extract the same logs and output using this command without getting into that particular container inside the container. So this is showing. So this command is used for getting container logs, and the previous command that I executed, inspect command, is used to diagnose the problem at the daemon level why a container is not coming up. These are the two best use cases of these two commands that you can use to find the problem why a particular container is having problem, whether it is the Docker daemon level issue or there is some problem inside the container itself. Then we can use docker container rm command to delete any particular container which is in stopped state. Let's do one thing. I will execute this for a running container and see what happens. This is my docker container rm command. I am going to delete our, let's say, web sys or ubuntu sys, any container. It is going to give me error, of course. As you can see, stop the container. Basically what it is saying, before, if you cannot delete, you cannot remove a running container, which is quite obvious, because if a container is running, there might be some services which are being served, and if we are going to delete it, my service may be impacted. So for the safety, for the consistency of your services which are running, assurance of your services which are running on the Docker daemon, this kind of restrictions are there. We can solve this problem in two ways, either by using forced deletion or by stopping the container first and then deleting it. So what I'll do is I will stop it and then I will delete it. It got deleted successfully without any error. Let's go and list it out. Container. Now there is only one running container. If I list all, then there is only two containers. Previously it was three. So you can see how you can delete, create, start, stop, inspect and logs, get the logs of the containers. Now there is another requirement that we generally use. The requirement is related to how to access the containers. Let's say we have created two containers. One is websys1. Let me delete this again and we'll create a proper one. Docker container. Here we are. Let's recreate. Here we are, Docker container ls. So we have two containers which are running. So we remember, right, we created Ubuntu system with the SSH access. We install SSH Open SSH tool and we can access it from outside. That means if we want to get inside the Ubuntu system container, we can access it over SSH and see all the details. But this is not the ideal case. Generally we only expose the services which are needed, and generally we don't enable SSH access to any Ubuntu system. I just did it to give you the difference how we are going to do it. But let's say we have two systems, Ubuntu 6 which has SSH access. From outside we can access and get inside and see the details and logs. But what if a container does not have any CLI or user interface to get into inside the containers like web system? For that purpose we need to use docker exec command. -t, which indicates iterative. That means after getting into it you can execute your commands, followed by the container ID that you want to access, and then the bash, that means you want to get into CLI access. You can see the prompt got changed. We are inside the container. You can match the container ID here. We are inside the container, and then after getting into it we can perform any functional command that is allowed to do here. However, we restrict them. There are very limited commands that we can run from here. So let's run curl command to the local host to see whether we are able to execute it or not. We are able to execute it using localhost. We are inside the container, we are getting output of the container page itself. We can access any other, let's say google.com. If we'll try to access it, we'll get something. We got output here also. So that means we are inside the container and we are able to execute all these functional commands here. Now let's do one more thing here. So we used a docker container logs command to list the containers logs from the inside the containers, right, on the Docker daemon itself. Now let's validate whatever log it had presented there, is it correct or not. So what we are going to do is we'll try to see the log file which is inside the container log httpd and then maybe error logs. Yeah, here we are. You can see we are able to see the same error that we got on the screen using the docker container logs command. Without even getting into the container, we can extract the logs on the Docker daemon itself. Now let's notice one thing. So by default, the system name, the container host name is same as the container ID. We can fix this problem. We can fix this requirement as well. So what we are going to do is, again we will execute the same command. This time we'll give it a name system4, and we will add additional syntax here saying that -- host name, followed by the whatever name you want to give. I'm going to give the same name. Let's change the port also, otherwise it will give error. Container got created. Now let's get into this container using docker container ls command to find the container ID, and then docker exec -t container ID, which is websys4. Here we are. and followed by the bash. We can see this time we are inside the container with the host name, which is same as the name that we defined while launching the container. So this is how you can give a host name to the container when you are creating for better identification, or you can let it be and you can choose it dynamically depending on the container ID what is given. So that's all for the day, and we have explored all the advanced commands which are useful for your daily operation to diagnose the problem related to your Docker daemon or container itself. That's all for the day. Hope you enjoyed watching. If you find it useful, please encourage us with your comments, likes, shares and subscriptions. Thanks for joining. Stay tuned for more videos.